Okay, writing scientific notation. Scientific notation just takes really large, numbers, not large numbers, larger numbers with a lot of digits, and it puts them into a simpler form. Okay, now, I have a question for you at the beginning. When you look at that number, is that less than one whole or bigger than one whole? It's less than one, okay? If it's less than one, you're going to put a negative sign, okay? Now, here's what you do. That's important for later. Starting on the left, you got to mark the first digit you come across that's not a zero. So, 0, 0, 0, it'd be 3. That decimal point has to be moved so it's behind the 3, between the 3 and the next number, okay? So move it, but count as you're moving it. 1, 2, 3, 4, 5. So now the decimal's here. It has a 3 in front of it, those zeros are dropped, and then 7. Now every time you move the decimal, you're actually multiplying by a 10. Well, you moved it 5 times, so it's going to be 10 to the 5th power, and since it was less than, you started with a number less than 1 and made it bigger, you're going to have a negative, okay? That's the answer. Okay, my next problem, 6,700,000, okay? Well, that number's obviously greater than 1, bigger than 1, or bigger, greater, whatever. That means the exponent will be positive. Now, the first number I come across is 6, that starting on the left. So the decimal needs to go between the 6 and the number after it, 7. Now, you're like, well, where the heck is a decimal? Those are commas. Well, we're going to put a decimal at the end. If you don't see it to start with, you put it at the end, but you still need to move it between the 6 and the next number. 1, 2, 3, 4, 5, 6. So you have 6.7, you don't need the extra zeros, times 10, and you moved it 1, 2, 3, 4, 5, 6, but it'll be positive 6 because the number you started with is bigger than 1. Okay, next problem. Bigger than 1 or less than 1? Obviously, 5,200,000 is greater than 1. So greater than 1 will indicate we need a positive exponent, okay? Another thing you could use, if you move the decimal to the right, it'll always be negative. If you move it to the left, it's a positive, but a lot of people struggle with that. Okay, so this is my first non-zero digit, okay? Right there, 5. Decimal's at the end, but you have to move it so it's between the 5 and the 2. So 1, 2, 3, 4, 5, 6. So now it's point, in front of it's a 5, behind it's a 2. We can drop the zeros. That's what scientific allows you to do. Times, and you're always going to use a base 10 because every time you move the decimal, it's by a factor of 10. But there'd be 6 factors of 10, so I put it to the 6th power, and it's positive. Okay, 5.2 times 10 to the 6th power. Now again, okay. Next one. Well, this one here looks like it's less than 1 whole, really small number. So that will mean we will have a negative exponent. Okay, now, starting on left, you find the first number that's not a 0. No, right there. So the decimal has to go between the 6 and the 4. So the decimal's here. It's going to be in different places. You need to move it so it's between the 6 and the 4. 1, 2, 3, 4, 5, 6. Okay, so 6.47. You put the 47 behind it, times 10, and I just moved the decimal 6 places. 1, 2, 3, 4, 5, 6. But it'll be negative 6. Okay? Because you started with a number less than 1. Now again, a couple different ways, there's many different ways to think about this. One thing, if you're moving it to the left, it'll be a positive. If you're moving it to the right, it'll be a negative. Okay, that's another way to think about it. Another way you can think about it is we made the number smaller here, so then we traded off by making the exponent positive. Here we made the number bigger, so then we traded off by making our exponent negative. It's like a trade-off. Okay. So when you make your original number bigger, the exponent will be negative as a trade-off. When you make your number smaller, the exponent will be positive as a trade-off. But I would just go with the greater 1, 1, less than 1. Okay. Okay, so right away, okay, this is bigger than 1, greater than 1. So right away I come across the very first digit's not a 0, so the decimal has to go between the 7 and the 0 after it. So where is the decimal? It's at the end if you don't have it, at the end, not at the beginning. So we need to now move it so it comes right after the 7 and the 0. So 1, 2, 3, 4, 5, 6. Okay, greater than 1 will make it positive. And also, other ways you can think about it, I'm moving to the left, it's going to be positive. I'm also taking a big number and shrinking it, making it smaller, so the trade-off will be that I have a positive exponent. So 0.7.0 times 10, we move the decimal 6 times, and it's positive 6. Okay, next problem, that's less than 1. Okay, so we'll be making the number bigger. Less than 1. So I trade off by making the exponent negative. Okay, so where does it go? Not here, 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 right there. Okay, so it's got to be between the 4 and the number right after it. Okay, so move the decimal. So it's between the 4 and the 2. 1, 2, 3, 4, 5. So decimal point, you have a 4 in front of it. Those extra zeros I should not see. That's the point of scientific notation. Times 10, and you moved it 1, 2, 3, 4, 5. Okay, but it's got to be a negative 5 because you moved it. The number you started with was less than 1. Okay. Okay, think. And you moved it to the right. Right's always going to be negative. You also made a small number bigger, so then you trade it off by making the exponent negative. It's a trade-off. Okay, next problem. That's bigger than 1. Bigger than 1 whole. So if it's bigger than 1, we think positive exponent. So where does the decimal go? Well, right away, the very first number is not a 0, so it goes between that number and the number after it. So where's the decimal to start with? It's at the end if you don't see it. So you need to move it so it's right after the 4. So 1, 2, 3. So I put my decimal, we got a 4 and then a 2. Okay, the zeros at the end drop, times a 10. It's always a 10. Okay, because every time you move a decimal, you're multiplying it by 10. Just watch this, I'll prove it. Let's say I take 33.52 and multiply by a 10. Okay, the decimal will move once to the right. See, it just moved. It's the same thing, it just moved it. So b to a 3, because you moved it 3 times, and bigger than 1 would be a positive 3. And you moved it left, so left is positive. The right-left thing confuses people. Just think, start with a number bigger than 1, you're going to use a positive power. Okay, start with a number less than 1, you're going to use a negative power. Okay, right there, that is less than 1. So I will be making the exponent negative, because I'm going to be making this bigger, a bigger number, so then the trade-off is that the exponent is a negative. So, no, right there, the 3. Okay, so decimal has to be between the 3 and the 6. 1, 2, 3, 4, 5. So point, you'd have a 3 in front, a 6 behind. Times 10, because every time you move the decimal, you're multiplying by a 10, and you moved it 5 times, and you moved it to the right, so it'd be, and it's less than 1, so it'd be a negative 5. Okay, now on the next page, you're just going to use your calculator. Now they give you the scientific number. Now you have to find the starting number. Just take your calculator, 2.73 times 10 caret, you can do negatives. So, again, that would be a really small number. When I have a negative exponent, I should expect that number to become smaller. Then if I go the other way, it comes back here. Okay, now take your 3.74 times 10 caret 7. Again, positive exponent, I would expect that number to become bigger. Okay, 374, 0, 0, 0, 0, 0. Okay, and then 5 times 10 caret negative 5. I would expect that number to become really small because it would be a negative exponent. Okay, 8.3 times 10 caret 8. Okay, I would expect that number to be a really big number. 0, 0, 0, 0, 0, 0, 0. Okay, I don't care if you put the commas, this number is actually 830 million. Okay.